In order to make a tissue, which is a bunch of the same cells connected together doing a function, we need to be able to hold cells together. And so there are a lot of cell junctions that occur between adjacent cells. A tight junction are these junctions up here that hold the tops of these cells very tightly together. So what this does is it creates this kind of waterproof connection between this cell and all the surrounding cells. And it makes the water that's in these areas, so this is the small intestine, so this would be the fluid in the small intestine, and it helps keep that moving through the intestine, and it can't get past these tight junctions. So none of the fluid from the small intestine is going to get past these cells unless it goes through the cell like it's supposed to. A desmosome are these guys right here that look kind of like wavy octopuses. And what these do is they're going to hold these two cells together almost like Velcro. There's a piece on this side and there's a piece on this side, and they're going to hold these two pieces of epithelial tissue together. Sometimes we see a hemidesmosome, which has only got one side of the Velcro, and those are used to help kind of anchor it to the basement membrane down here. And then a gap junction are going to provide tunnels between adjacent cells. So we have these gap junctions down here that are going to allow fluid to move through from one cell to the next without having to go out of the cell membrane and into another cell membrane. It creates a cytoplasm to cytoplasm connection between adjacent cells. Glands are a functional type of tissue, and we have two main types of glands in our body. So most glands start at the surface of an epithelial tissue, and that epithelial tissue will start to grow down into the body. And it starts to create kind of a long epithelial cord or tubule. And then one of two things happens. It's going to become an exocrine gland. So exo means outside. In an exocrine gland, it's going to maintain its connection to the outside. So this would be something like a sweat gland, where it's going to release its particles out onto the surface of the epithelium tissue. Or it will become an endocrine gland. So endo means inside. Endocrine glands lose that connection to the outside. So here's my gland, and instead of releasing it to the surface, it's going to end up releasing its contents to the blood. And we're not gonna cover endocrine glands in this semester. You'll study those in chapter 17 in Anatomy and Physiology 2. Exocrine glands are a cellular surface that's going to release its contents to the outside. So it maintains that connection to the epithelial surface. And there are a couple of different structures that can be formed. A exocrine gland can be simple, meaning it's got a single tube like this. Or it can be compound, where you have multiple tubules kind of compound together. So this one's got 1, 2, 3, and then this one's only got one exit. So in a compound tube, you're going to exit into a small tube here, and then we're going to have multiple tubes kind of coming together to this one exit for compound. They can be a tubular shape, so this is going to be like long and coiled. Acinar, so acinar is typically when they have a secretory bulb. And then tubuloacinar is where the tube part and the bulbous part are both producing glandular secretions. So throughout the body, we're going to find many different types of membranes. A cutaneous membrane is like our skin. So like if you look at your arm, that's your skin. And a cutaneous membrane is going to be made up of our stratified squamous epithelium, and it's on top of a connective tissue of loose areolar connective tissue. And these cutaneous membranes are going to help us prevent dehydration, resist bacterial growth. We're going to talk a lot more about these in chapter 6. when we talk about the integumentary system. So mucous membranes line the passages in our body that open to the exterior. So think like your mouth and your nose, the vagina, the urethra, the anus. Those are all openings into our body that kind of lead to an exterior pathway. And they are surrounded with this mucus coating. And this mucus coating is going to help trap particles that you might breathe in through the air, and then it's going to help get rid of these particles so that they don't end up in the lungs. A serous membrane is found inside of body cavities. So this is going to be maybe inside the lungs, where we've got a single layer of cells here, and there's a tiny little layer of fluid on top of those called serous fluid. And this fluid in the lungs is called surfactant, and it actually helps aid in breathing. And so this is what you're going to find lining most of the internal body cavities that aren't very closely open to the exterior of the body, like inside the lungs or arteries and veins. So we have several different terms for describing kind of the growth and development of a tissue. So if this is our normal tissue, we've got a simple, because it's only one layer, cube epithelium. Atrophy of a tissue is when a tissue remains the same number of cells, but those cells get smaller. This happens in muscle cells when we don't use them. Hypertrophy, so hyper means more. This is when we have the same number of cells, so it's still the same 4 cells, but these cells are growing by becoming larger. So this is going to happen in muscles and in adipose tissue. So this is how muscle cells and fat cells grow. Most other tissues, like epithelium, grow through something called hyperplasia. So hyper again means more. Plasia is going to be the cell division. So now instead of 4 cells, we actually have 8 cells, I think. 7 cells here. So some of those cells divided into 2 cells, and now the cells aren't really any bigger than they were originally, but there's more of them. When cells change what type of cell they are, that's called differentiation. So changing from like a stem cell into a heart cell is called differentiation, and that's normal. What's not normal is metaplasia, where it changes from one mature form to another. So being a mature heart cell into a cancerous cell, or a mature lymph cell into a cancerous cell. So metaphasia happens typically with the growth of tumors, where a cell will mutate and then change into a different type of cell that we would consider cancerous. And then dysplasia is when some of those actually break off and then are able to move to different locations. A stem cell is any kind of cell that isn't differentiated yet, so it doesn't have its final purpose. If you think about it, when you were first made, you were one single cell, and then eventually you were 2 cells and 3 cells, or 2 cells and 4 cells and 8 cells and 16 cells, until you were a little ball of cells called a blastula. And none of those cells had a specific purpose yet, right? Like you didn't have a heart or a brain or skin or anything at that point. All of the cells were just the same, so they would have been considered stem cells, specifically embryonic stem cells. And those are called totipotent, meaning total for toti, potent is potential. So all of these cells in your original cell to your blastula form had the potential to become every cell in your body. As an adult, you do have some types of stem cells, but they're not total potential. They're multipotent, meaning they have either many potentials, or unipotent, meaning they only transform into one potential type of cell. So an example of a multipotent cell would be the bone marrow is multipotent because it can make red blood cells, it can make white blood cells, and it can make platelets. And so there's multiple different types of cells that can come from the stem cells in the bone marrow. An example of a unipotent cell would be the precursors that make either eggs or sperm. So you actually have a precursor cell that develops into an egg in females and a different one in males that develops into sperm. But those can't develop into any other cells. They either develop into eggs or they don't. And so that's only one potential. When our tissues get damaged, we have to repair them. And tissue repair can happen in one or two different types of ways. We either repair the cells by replacing them. So regeneration is where we're going to do things like mitosis and replace cells with new cells. Fibrosis occurs in areas where we don't do mitosis. So you're going to end up with things like scar tissue to fill in that space. So this woman was chopping vegetables. She got a cut on her finger. The skin is a really good example because it has both of these in it. So here's my basement membrane. Up here we have the epidermis, which has living cells right here, are able to do mitosis. So you can see in the regenerated tissue that we were able to make a whole bunch of new epithelial cells to fill in that damaged area. But down here, this is a loose areolar connective tissue in the dermis. And this is not going to be able to reproduce these cells. There's not very many cells in here. This is mostly collagen fibers. So what it's going to do is going to fill these with fibers, and you can see that scar tissue here. So the deeper the cut, the more scar tissue you have is more likely to leave a scar. And then we have lots of different types of tissue death. So atrophy, we kind of showed already, was the loss in cell size or number. And this is normal with lack of use of things like muscles. So those would become smaller. Necrosis is premature death. So it's going to happen prematurely from some kind of pathology, which is some kind of disease. An infarction is a sudden death because of lack of blood flow. That should be of. So we have two types of infarction that we study. Myocardial infarction, which is a heart attack. So that's sudden death of the heart tissue, or stroke. So that's sudden death of brain tissue. And that's going to happen because the oxygen's not flowing, so that tissue is going to all of a sudden die. Gangrene, so that's what you can see down here. And this is a slow death, but same thing with lack of blood supply. So this is common in people who are in really cold climates that don't properly protect their arms or their digits that are far away. So when you're really cold, your body tries to maintain its body temperature by not sending very much blood flow to your fingers and toes. And if that persists for a long period of time, those tissues can actually become necrotic and start to die. Apoptosis is a programmed cell death. So this would be totally normal. We program cells to go through apoptosis all of the time. We use this as a mechanism for getting rid of cancer cells. Everybody, when you were in your mother's uterus, had webbing between your fingers and toes. And before you were born, most likely, the webbing between your fingers went through apoptosis to remove that. So what happens is this is kind of like when a construction site goes through demolition and they implode a building. So instead of exploding, what's happening is this cell is actually imploding and then releasing these little blebs off of the surface. And then eventually the entire cell will get broken down in a very organized, controlled manner. Take a moment and compare and contrast between the structures of endocrine glands and exocrine glands.